Okay. Good afternoon. This is the Friday, the last day, the last session, or close to it. We have last track of the broadband track. So we have 4 talk lined up today, and first of all is this talk, and then I'm very bad with this, and then Eris has one presentation. No, CommScope. And AT&T has one more presentation, and then end with who's that? Okay, EdgeCore has a fourth one. So we have been very successful 2 days, and I'm sure today will be even more exciting. So let me introduce to Shai and Tina to start the talk today.
Thanks everybody. So my name is Shai Tsou. I'm the ecosystem lead on the Crano project, the business lead for ARM, where I work in the infrastructure line of business, working with our partners in the ecosystem to develop ARM-based solutions for networking and infrastructure. Tina will introduce herself in a minute. And we want to present the work that we are doing kind of in the edge in general as ARM, and more specifically the work that we've been doing in the ecosystem around Seba and the Seba blueprint. So I'm just going to do a quick introduction just around what we're doing with the ARM infrastructure group, and then I'll hand it over to Tina. So some people know ARM, some people don't know ARM. Basically, as an IP company, we work with a broad ecosystem of software and hardware partners. So we license our IP to companies who build chips around that IP. And as a result, the ARM ecosystem taken as a whole is unique in that it's essentially in everything, right? So, you can find ARM-based processors in everything starting from IoT sensors up to and including, data center servers and everything in between. And this gives us an advantage as ARM to kind of take a kind of a 30,000-foot view of where the industry is going, what the interesting trends are in edge computing, and see how we can, help guide the ecosystem towards projects that make sense to kind of leverage the advantages of ARM processors. So there we go. So as I said, we're in a unique position that we're the ARM to cloud vendor. So if you look at the network traditionally, the data is actually flown. If you look at this screen, the data is today mostly flowing from right to left. So if you think about Netflix, you think about video, it's a lot of data being pushed from mega data centers to the devices. Whereas in a very short period of time, we think that equation is going to flip itself. And what you're going to see is actually data being generated by the devices and increasingly being pushed the other way, but it won't get pushed all the way because the network can't handle the data coming from 1 trillion devices, which we foresee in the short-term future. And really the trick will be, what do you do along the way with that data? And finding what the solutions are for processing it in different spaces along the way, and really only the necessary data that really needs to be stored gets pushed all the way back to the cloud. So what's interesting about about ARM is that because we have a wide ecosystem of partners, each one of them take the base IP and then add their own what's called special sauce to it. It means that we have the ability to provide the right amount of compute, the right amount of storage, the right amount of networking, given the specific use cases. And this is going to be a demand for the edge as you get multiplicity of use cases, everything from processing that needs to be done in lampposts to to POPs to other things. And the ARM family of devices, which includes the traditional IP, the Cortex brand, Cortex-A, Cortex-M chips that you find in your mobile devices, embedded devices, and things like that, is also being joined by the new ARM Neoverse family, which is infrastructure focused. So it's focused on both massive throughput or heavy processing power, together with ARM's IoT management platform called Pelion. So, like I said, we have the flexibility to really provide the use cases. And one of the use cases that we want to talk about today is the work we're doing with Seba, and I'm going to hand off to Tina at this point to discuss that.
Can you hear me? Yeah. So this is Tina Tsou. I'm an enterprise architect in ARM. I recruit and management dozens of engineers to do the open source software development for like Equino Edge Stack and Sun Linux Foundation project, and also for ONF and OCP and TIPS, etc. And at the same time, I'm leading the ARM edge computing team within the company across the different BG like IPG and ISG. IPG is where we produce all the IPs So I'm leading the ARM edge computing team in the company. IPG is more where we create and produce all the IPs, and ISG is more for the services like IoT, automotive, etc. And then at the same time, I'm the technical steering committee co-chair of Equino Edge Stack, which is under LF Edge and Linux Foundation. So today I'm going to introduce Seba and how ARM contributes to Seba as an ecosystem with all our partners and customers. So Seba will allow the operators to run VRT access and aggregation applications at all the locations and thousands of edge locations. On Monday, we heard from Andre from AT&T, the CTO, and also the president of AT&T Lab, saying they are deploying at the homes of Texas, and also there was Atlanta, right? Yeah, for 500 to 1,000 homes. That's what I heard at the keynote. And we can automate the installation of all the standardized set of hardware to accelerate all the deployments. I think because the margin in the access market, access network is very thin. We have to accelerate the deployment and make this TCO benefit to accelerate the expected deployment. Also, the deployment models can scale, like today you have 500 to 1,000. Maybe in the future, in your plan, you can scale and cross thousands of locations of all the United States. But of course, I see like Deutsche Telekom and Turkish Telecom, and who else? Yeah, forgot. This morning showing the demo. Yeah, I think it's very good, the user story we can take. So every side of Seba is self-contained. It can pre-integrate the solutions containing all the network elements, like we have the ONF, VOTA, and the NAME, all these components. It's self-contained, and within different network elements and compute node, and control node, and software components. I think Seba is more the control plane for the software-defined broadband access for the white box VoLT. So all the solutions we are focusing on is the container-based solutions. I already mentioned the VOTA, ONAS, and NAME, etc. Each site should support and can support up to 16 OLT, and there are like 16K subscribers. I think this is the scale we're looking for. If you have any questions, you can feel free to stop me anytime. How do I flip? Oh, got it. Okay. Thank you for flipping. Okay, so this is one slide show the ARM activities on Seba. And so I guess people here are familiar with this Seba pod here. You see we have Seba pod like the Edge Core OLT supporting OpenFlow. Then it becomes an aggregate for the ONU here. Then it goes to the aggregation switches, and all the compute node is under as a data plane, but Seba the whole is running as a control plane. Then it goes to the AT&T external BNGs. We also have the BNG project here in ONF. Myself co-chairing the Equino TSC. Also, ARM ecosystem is leading Seba validation on ARM as a work stream within Equino, and Julie is the PTR of that blueprint. It's basically integrate and tested all the Seba software, open source software we created in ONF. And then the IEC, we integrate Seba into the integrated edge cloud family of the blueprints. IEC is a Kubernetes-based OS platform, which can support both x86 and ARM, especially the AR64 architecture. Also, ARM is leading the multi-arch brigade within the ONF Seba group. This brigade is mainly to support and enable Seba on the multi-architecture like x86 and ARM. So the current progress is that we have already set up the pod for testing, and now the next step is to run the CI/CD environment and testing within ONF. Because within the Equino Seba blueprint work, we found out some of the patches which to support the multi-architecture. Why didn't we just do it in Equino? Because we don't want to take any technical depths. We don't want to fork ONF. That's why we come back to ONF as the upstream community and submit our patches. To submit these patches to be merged, we have to show it really works on the ONF platform as a whole. That's why we created this, which is called multi-arch brigade, like a subgroup here. We have done a Seba Demo on NPR service in April this year during the ONS North America. I would like to show you the Seba Demo right here. Okay, so basically we create, is it moving, right?
Yeah.
Yep.
So we create instances, you can see here. You can, like, just let it play, yeah. So we can just plug in, drag and plug, just drag all this, see. We have these organizations, we drag one device, we add it. It's based on the NPR servers, which part of Equino IEC. Then after that, you will see we have the speed testing. And when we add it, the administration status will become enabled and online. So it's very basic broadband access use cases. Let's see where it's doing. Yeah, okay, so yeah, it dragged into here to the NPR1. So it simulated the ORT. And now you can see from the dashboard here. See, okay, now you see all the green part, the ORT devices is synchronizing. Okay, now it's done. One more, the last one. Yeah. No, it's just automatic going, yeah. So we already created one, yeah. We're dragging more, and all of the code has been uploaded to here to, if it's validation integration, it's uploaded to Equino Seba blueprint. If it changes to ONF, we upload the code to here. But some of them are the patches under review. Yeah, so we create another one. You can see the ONU devices also created here. Now you see the speed, like go into the red part. Yeah. Okay, I think this is pretty much showing you like a more visual how we can see how an administrator, operator, they can use Seba. The other side here, if you click this link, can you click? I'm sorry, I'm just running the engineer play here. This link goes to a wiki page, which is the Seba validation arm. In Equino, we have the community lab, which is more like the central community lab. But for each blueprint, we have the validation lab there. Each validation lab validated its own blueprint, then send the, so there's a CI/CD pipeline between the community lab and each validation labs. And also the Jenkins slaves connect to the Jenkins master in the community lab, and also push the logs every day, daily, automatic, run all the scripts and all the scripts. Yeah. So there were two parts, which is additional validation lab in Equino for Seba. ThunderX2 Part 1 and Part 2, they are almost identical except the IP address and IPMI. You can see here we have a gigabyte Part 1 because ThunderX2 is the Marvel's name, but it's ODM by the gigabyte. So it's just connected as a 3-part 3 server pod to run Seba. It's the typical Seba, but ThunderX2 is based on ARM architecture and IPs. So you can see both of them runs CentOS and also runs Kubernetes. It takes Seba 1.0. But if Seba here in ONF migrated to Seba 2.0, I think Equino Seba is happy to take the latest version if possible. Yeah, I already see a lot of good features added up there. Next, please. Yeah. So we think about the key challenges for Seba. We already see because there are a lot of remote deployment at thousands of edge locations. That's why the automation is very important. We really look for the automated installation of a standard set of hardware so that we can accelerate the deployment, as I said before. This year we have Texas and Atlanta, and maybe next year it could be even roll out to the other cities in the States. And the other point is the power consumption. We think, because in the Seba blueprint, there's a power consumption requirements, which is restricted to less than 1 kilowatt and includes NEBS compliance and 48 volt DC. That's why we think the solution to that is the multi-core CPU solutions, which can deliver the competitive performance per watt.
And this goes back to what we were saying before about being able to have a.
Yeah.
This goes back to what we were saying before about having an architecture that's flexible enough to be able to provide that level of power and performance at kind of the restricted power envelope, or in some cases a restricted physical footprint. And so I think the next one's the.
Yeah, which is called
Yes.
green computing.
Yeah, so go.
Yeah, so that's why we presented the ARM solutions here. The ARM ecosystem has a wider set of solutions which we can hopefully optimize the Seba use cases based on the performance restrict that we just mentioned about, and also support the remote deployment. So ARM ecosystem has a lot of system or chip partners, like you probably heard Marvell, Ampere, and Qualcomm. They provide the multiple hardware solutions which can match this power and performance area needs, like the same power, maybe it's cheaper, or lowest power. That's what we're looking for. This is how we call it the TCO, the performance per watt. And also Marvell and Ampere is two different flavors of ARM SoC vendors. They provide different solutions, but the same Seba. Let's take Seba blueprint as a car. Then for different deployments, like in AT&T or Deutsche Telekom, you can have different passengers, or different flavor you can pick from ARM, Ampere, or HPE, whatever, to load your passengers to the same car. That's why we're building the cars, building blueprint in Equino. So Seba leverages ARM work in the IEC blueprint family. As I said, this is more like a lower layer software stack, which if you want to run on ARM, it just gives you the right combination of integration of Kubernetes, CentOS, and Calico, etc. Even we don't use Calico here, yeah. There are better latency for end users. As we can see in the optimal edge zone, it asks for less than 20 milliseconds. And also the network should be less load, and since more data can be processed locally. That's why we need edge computing. The connection we can do is above the 10 gigabits, which may meet most of the requirements. And finally, we have to fully use the computation power to the edge devices. There are two kinds of deployment. The small one is more for micro Mac, local gateways, and small board, which is less than 10 watt for the SoC. Medium deployment is more for the edge cloud service. It's less than 100 watt for the SoC. So this is the estimate and actual provide power consumption for all the different scales of the deployments. Any questions so far? No? Okay. Okay, so a lot of people wasn't sure what ARM is providing. So it's diversity. We have a broad socket design options with ARM. From the bottom, you can see we have the ARM architecture, VA.X, then all the common software platform ecosystem runs on this. And then you send to the foundry, like TSMC, 7FF, etc. Then you provide I/O out for the interconnection, like PCIe, CCIX. Yeah, maybe one day it's the CML. And the memory, we have all these kind of memories. And the accelerators, they were kind of the machine learning or the smart NIC you can provide from here. On the top is our most common offering to the industry. One side is like ARM IP. You can provide to like Marvell, Ampere, NSP, etc., Broadcom. And the ARM architecture design, like we provide to Apple and Qualcomm. And also our customer include Google and also Microsoft, and most recently, actually last year, is AWS EC2A1 runs on the Graviton, which is designed in AWS. They run it daily, which is on ARM. Okay, any questions for this one? Since not. Okay, so here comes our ARM Neoverse, because in the previous picture, you see the ARM Cortex, ARM Neoverse, and ARM Palladium. ARM Neoverse is the from cloud to the edge infrastructure, which will serve the world of 1T devices, which is, we have 3 main aspects: high performance, secure IP and architecture, and we support diverse solutions ecosystem based on ARM IP or ARM architecture. It's scalable from hyperscaler to the edge. You see the previous page has the IoT devices. Then you have the local services, which is called like gateways or the small boxes on the either light poles or in between the base station and the light poles. And then it comes to the infrastructure services, like all the telcos backhaul all the way from the gateways to the edge servers. It's all we call infrastructure services. And then above that, you have edge cloud, more like the cloud CO point, the central office point. That's where the edge cloud is. And not only the edge computing, we also expanded to public and private cloud, which is for the hyperscalers. Okay, so now I'm going to presenting 2 examples of our ecosystem offering. One is from Ampere, and the other is from Marvell. So this is Ampere slides. So they feel like why Ampere in the edge? It's because it's scalable with 8 to 32 cores. It's also powerful because they have the number. If you are more interested what the power number is, please contact the sales guy. We have an email on the next page. You can contact them for the detailed numbers. And also, it's more efficient for high-performance CPU. Also, it supports the wider software ecosystems, Linux, Windows, hypervisors, etc. And it's also reliable for the long life cycle support. Yeah, this picture shows how it looks like, Ampere server. This is the same we show at the ONF North American in April, back to in April. So you can see this is complying with the OCP design, the OCP open standard. Or
the OCP Open Edge.
Yeah, Open Edge is a working group at the telco categories within OCP. So it's compatible with the chassis CPU sled, and there are 32 and 16 cores SKUs. And you can see the processors, it use ARM V8 64-bit CPU cores, and with the 3.3 gigahertz turbo. Sorry. Memory, I/O, power, performance, you got all the availabilities and the numbers. And that's how it looks like with the Power BMC and the OCP riser from the other side. Any questions for the Ampere, the previous one? Any questions for that? Okay. You already switched to Marvel? Okay. So this is another option, which is Marvel, also complying with OCP. This is the design. You can see the form factors, kind of proprietary, but the processor support, it has 32 cores, 128 threads. The chipset is SOC, the memory lane, and the BMC. The storage has 2 SATA. They have the raw I/O is like, and the connectors. All the numbers are here. I think you can get more information about this specific Marvell OpenEdge ARM server board details here. It's under the server processors under the Marvell official website. Any questions about the Marvell one? You flick to kick?
Yeah,
okay.
We have to wrap up. So
Okay. Oh, sure.
running towards the end.
Okay. So yeah, I was going to expand the Seba user story actually. Julie kind of on this. I just steal your slides for this, like more abstract, because we have many steps. As a provider, as a service provider, I want to set up the Seba environment so I can use the ONF Seba platform. But as administrators, I have 4 steps. First, I want to validate the host OS environment so I can install the Kubernetes Seba. And then I want to validate the software environment so I can also install the Kubernetes and Seba. And the third step, I want to validate the VMs for Kubernetes Seba I just set up so that I can validate my environment. After I validate my environment, I can validate the services. Like we see, you can go to the broadband access. Any applications you do in the broadband access is part of it. Validate for my Kubernetes Seba environment, so we can validate the working environment. So this is a user story. I think it's very important to let people understand as a service provider and as administrators how we are going to use Seba. Next, please. Okay. In summary, so Seba solves both the residential access and the wireless backhaul problem. I think this is in line with what ONF is doing. And ARM enables the development in Seba. Also, there are multiple ARM solutions for optimize the Seba deployment for the power and remote deployment. Finally, there is a blog from LF Edge website that you can have a look how we do the demo of Seba on Ampere servers. And the last one, if you're interested to contribute to Seba in Akrino for the validation, integration, CI/CD, you can go to this this link to find all the information, or after this talk and during the break, contact our powerful PTL, Judy. Okay, that's about what we bring to you today.
Any question? Would like to? Well, thanks, Shai and Tina, for the presentation. Thanks.
Thank you for having us.